Good morning, Dr. Paul Swan. How are you today?
I'm well, thanks, Heather, and good to see that you're in good spirits there.
Yeah, it's very early in the morning here too, so that's always a good thing. Now, today we're going to be we're having a webinar on teaching with tiles. So it's a very simple but versatile manipulative that we can use. We've actually used it for geometry, for maths, for patterning, for sorting. I know that with my children, I've actually also used it for literacy. So when my son's language was not so wonderful, I used to put letters on the front and we used to name out cat and dog and all these other different spelling letters. So I'm looking forward today to seeing what else we can do with mathematics and, maybe a little bit of algebra. Is there maybe a little bit of algebra
There's
or anything
all
as
sorts
well?
in today.
A little bit more complex. If anyone wants to join in today, please go to drpaulswan.com.au and he has a sheet. You can cut out the tiles to join in. He's also got a lot of puzzles that you can join in and you can reuse as well. So I'm not going to waste any time. I'm going to hand over to Dr. Paul Swan. Thank you very much.
Thanks, Heather. So just a short thing here. So Heather mentioned you can download a sheet that I'll just hold up there, and literally you can cut the tiles out. Now, color tiles are typically 25 millimeter by 25 millimeter squares in 4 colors. So they're the old 1 inch, but they come in 4 separate colors. We'll play with them in a minute. And there'll be a second follow-up sheet that'll come with that. I'll do 1 or 2 of the puzzles from there, but there are a couple of ideas for some puzzles that you might like to try. So anyway, we'll get started, and I'll just talk a little bit about the tiles and what they can be used for. Now, essentially what we're talking about, as we said, is just some colored, I'm using foam versions of the tiles, but they'll come in 4 separate colors. So you've got the standard green, blue, red, and yellow that would happen there. And essentially anything that you could do with a counter, you can pretty well do with color tiles. So I'll review a few of those sort of things first, but then I'll talk about the advantage of the color tile in the sense that really, if you think about it, it's covering an area and it's a nice square unit. So there's some nice links into things like perimeter and area and measurement. But I'll just head you down to our little display area here, and you'll be able to see a few things that we're going to do with the tiles in particular. So I just took a handful of tiles or a couple of handfuls out. I'll move some of them out and so forth. But let's just look at a couple of things you might do with it. For example, for working with young children, we might talk about the idea of addition. So in this case here, I've got 3 tiles and you can see them pretty clearly, they're green. And we might say, well, when I add or combine some more tiles, so I'll show you some more that happens here. How many do we have all together? So you see there I had 3 and I added or joined 3 more. But if I joined this many more, you could see that all together I've got 8 tiles. So there's your stock standard idea for addition, which is joining. They could do that with counters, but it works equally as well with tiles. Of course, the other idea that I could have, so imagine I've only got those tiles here, maybe I've got 6 tiles, we can actually take 1 away or subtract, remove. And so we can do our addition and our subtraction ideas with the tiles and so forth. Now, let's just take a step further. So we've just looked at addition and subtraction. What about multiplication and things like multiplication and division? So with that, what we would make is a rectangle or an array. So I'll take you back in and have a bit of a look at how this arrangement looks. So I'll show you here, once again, we've got some red tiles. Now in this case here, I would say that there are 2 rows of 4 and altogether there's 8 tiles that sit there. And I could ask, so basically I've got 2 4s, all right? If I turn that around, and it looked a little bit like this, I've got 4 2s are 8. So you can start to see the sort of rectangular nature. I now have 4 rows of 2 that are happening there. So I'm getting the idea of 2 4s and 4 2s will give me that same result. And that's known as the commutative property of addition. It helps with things like learning the tables and so forth. So you can start to see some pretty basic number sort of ideas come out of that. But there's a couple of other things that sort of worth thinking about as well. And one is doing a bit of reasoning. And when I say reasoning, what I mean is, questions like, why is it that when I add 2 odd numbers, I get an even number? So once again, I'll get you to have a look and we'll set it up as an odd number and I'll show you what I mean with that. So odd numbers, if we work on pairs, so you can see we're going 2 wide. So here's an odd number, you can see 5, okay? And you'll notice there that it's got a piece sticking out and so forth. Now, if I add another odd number to it, just have a bit of a look. when I have the two bits that are sticking out, notice there's nothing that sticks out over the top here. So just a notion here of this idea that when I add two odd numbers, I get an even number. So there's some sort of thinking that happens when you start playing with the tiles. Now, Heather mentioned earlier the idea that there might be some algebra in here. So what we're looking at is things like number patterns. So the square tiles are perfect for examining certain number patterns. I'll give you an example. So if you have a look here, I'll use a red tile first to show a particular number pattern, and then you'll just see how it develops. So if you have a look at the picture there, you can see that I've got one tile, and then I've got a 2 by 2 arrangement. I've got 4 tiles. If I use a different color here, you can start to see that that's going to be 3 by 3, and I'll end up using 9 tiles. And so what I'm developing here are the square numbers. And it's pretty handy that these are squares in themselves, because when the pattern finishes, we get this square number. I often ask people, why do we call the square numbers? And the literal answer is because when you form them, they make a square, is what you can sort of see here. So we start to get the idea. The next one in that pattern would be 4 by 4 and 5 by 5. And so we're building this idea of the square numbers and so forth. So that's a lot of the sort of the number work, the algebra sort of stuff that sits with the tiles. But now I'd like to just sort of develop a couple of other thoughts that might happen. Now, one, of course, is that we can do some geometry with these sort of tiles. So I'll give you an example. I'm going to build half of something, and we're going to have a line of symmetry running down the center. And so then you would build the mirror image of what I'm about to build. So once again, I'll just use some different tiles here, and you'll be able to see as you look down on the screen there, you'll be able to see how it looks. Okay, so in this case here, I've built this example, pretty simple, but there's one half. And imagine down here, I then have a line of symmetry. Now, what that means is I then need to mirror this idea, or you can call it a copycat or something of that nature, depends on the age of the child. And you can start to see the symmetrical nature of what's been built in this particular case. You can see there's a line of symmetry is going to run down here, that there's a repeat. Now, strictly speaking, we'd have blue on one side and blue on the other. But what I wanted to do was do the mirror so it was clear to see. So you start to see how we're developing some geometric ideas, and sitting under that notion of geometry, we have the idea about how shapes are developed, how they're moved, and this idea of the symmetry, as we mentioned before. So that would be an example. Let's have a look then, and I'll take an example that we had a 3 by 3 little array, and I'll put it together so you can see. And what I'm going to do is use some slightly different colors. And that's the nice part about the color tiles, is to illustrate things, you can put different colors in different spots. So it's nice and clear. So if you have a look now at this, I've just built this shape, and you'll start to see what's happening here. And you'll see that basically it's a 3 by 3 setup here. But what I've done is put red tiles into the corner. Now, here's a little puzzle that we might sort of want to think about. And once again, I'm going to use a particular idea here, and that is that blue tile represents an area of 1 square unit. I'm not going to call it centimeters. I'm going to refer to millimeters or inches or anything like that. Basically, that tile has an area of 1 square unit. So if you look here and we have a look at what I've just built, you can see that that would represent an area of 9 square units. Now, I want to talk now about the difference between area and perimeter, and lots of children get a bit messed up about the idea of area and perimeter. So you're happy, what it covers, area is about covering something. It's the flat surface being covered, and what we just had there were 9 tiles or 9 square units that were being covered. Now, perimeter comes the word from perimeter, which literally means to measure around. So we're going around the outside. So for example, fencing would be an example of the idea of perimeter, going around something. So let's have a look here and let's compare the area of what I just built to the perimeter. So we're happy that the area is 9 square units, but for the perimeter, we would count on the outside. So I've got 1, 2, 3. So there's 3 that way, 4, 5, 6, 7, 8, 9, 10, 11, 12 units of perimeter. So in other words, what's going around there? with each one of these being representing one length unit. So we've got an area of 9, but a perimeter of 12. Now here's where the thinking has to come in, the reasoning comes in, because there's some people try and link area and perimeter together. Now they don't, not naturally, there's no formula that links them together, so to speak. So for example, what I would like to do is maintain the same perimeter, but reduce the area. So if you have a look here, if you have another look at what I've just built, what I'm going to show you is how we can make a change. So for example, if I remove that red tile, we're happy that the area has been reduced to 8 square units. But what's happened to the perimeter? Well, in fact, if we now go back and have a look at the perimeter, it stayed the same. So let's count and just double check about that in this case. So in here we had 1 unit and that was going that way. Well, it's now going this way. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we still have 12 units of perimeter, but only 8 units of area. Now, using that same reasoning, let's reduce the area again. If I pull out another one of those tiles, we can see that we now only have an area of 7 square units, but the perimeter is actually still 12 units. Let's pull out another one. So if we pull that one out there, you can start to see that the area has been reduced, but the perimeter stays the same. Now, in one of the sheets that you can download, I've put a puzzle along those sort of lines. It gets children thinking a little bit about, okay, so this is the area, it's what we're covering, and let's compare it to this notion of the perimeter of what goes around the outside. So you can see that what I like about tiles, the color tiles, is the versatility. So as I said, we can do everything we can do with a counter. We can do all of that. We can do the addition, subtraction, some multiplication, even division if need be. We can be doing some geometry and some measurement while we're doing that. So now let's just pick up on a couple of those ideas and extend them a little bit further. So for example, I'm just going to use a 10 frame, pretty common sort of tool that people use here. This one has some nice little wells in here so things don't move around. So I'm going to put that onto our screen here and I'll just show you a couple of things that we might do with that. Okay, once again, it's pretty handy that we've got different colors in these. So with the 10 frame, you'll see that the standard color tile fits onto it. How good's that? And we normally fill a 10 frame from the top left-hand corner. We might say you fill the top deck of the double-decker bus. And so I'm going to fill that, in this case here, with 7 blue tiles. And then I might ask a few questions. So how many more do I need to make 10? Well, I could show that with different color tiles. So in this case here, I could have 1, 2, and 3. And so now I've illustrated that 7 and 3 is 10. Or I could literally take 3 away from 10 and you'll see that we've got 7. So sometimes when you pair up the color tile with another tool like the 10 frame, it can help you a lot with that sort of thing. So I just wanted to build the notion that we've got some number work happening, but it's not just number work, and the versatility is really neat. Now here's a pretty simple idea, and this has to do with probability and statistics. So we've done number, we've done some geometry, we've done some measurement, but let's get into the statistics side of things. So if you think about it today, we really need to understand, get the statistical thinking happening. Now for young kids, that means we need to understand the idea of graphs. And so basically what I'm going to do is form a very simple graph. Now, you could do something similar with cubes. They can be joined together to form a graph, but we're just going to make a pretty simple graph here. And I'll explain what we're about to do. So for younger children, I would just say all they have to do is dip their hand into, say, like a mystery bag or something like that, and grab a handful of tiles. Now, that might be my handful, just about covers. I can't quite lift it up. Okay, so I'll put those off to one side and I'll put my handful of tiles down. I've grabbed a handful of tiles, and now what I need to do is sort them. So I'm going to sort them by color, but when I sort them, I'm going to sort them into what looks a bit like a bar graph, and you'll see what I mean here. I'm putting all the blue ones together, and as long as I keep them the same distance apart, we'll start to build a graph, and I might put the red ones here. And as you can start to see, at this point here, what we're building is a graph. Pretty simple idea. And oh, there's another blue one. And we might put the green ones here. And you can start to see that it turned out that I collected more green, looks like more green than anything else. And you start to see how a graph builds up. Now we're going to have to do some things to do with graphs. Now with graphs, we want to make sure the base is all the same. So I'm just going to put this in here and we'll just get the base, and then I'm going to move it down because we need some more that would sit in here. So they all need to be sitting on the same base idea, or we'll call it an axis later on when we play with this. And so straight away, we can start to get a picture here of some questions we might ask. And if I have a look here, that's just finishing it on. So here we've formed our little graph. And remember, we're young children, so we're just building this idea of graphs. But as long as we've lined them up, there we go, it's pretty good. You can start to ask some questions here. So the questions might be, what color was the most? Or what was the least? Or how many did I pick up altogether? And you start to build the ability to read a graph. So it's one thing to create or make a graph, but it's quite another to interrogate it or learn to read what it's saying. Now I'm going to take it a step further just to show how a simple task like this can build and build and build, and we'll follow it through a little bit. Okay, so if you look here, I've got my colors and we've got a little graph that's by color. Now, remember we talked about putting an axis in. So at this point here, we might put this axis in, and then we might put something for B for blue. We might put R for red, and G for green, and Y for yellow. And so now we've built up this idea of what's sitting on this bit, and then we can then start to build another axis. Now, it doesn't have to be perfect at this point, but what children are starting to build is the idea of, after a while, we can put a bit of a scale on here, and you can see it matches nicely and follow it through and so forth. And we could even number that if we want. So we can put the 1 and 2 and 3. You're getting the idea. And so from this sort of start, what we're building is the idea of a graph and what might happen. Now, eventually, when we take some of these pieces away, and for example, we might have got up to 4, 5, and I think it went to 6. We can start now to replace that, and we can now put in our rough bars. And so now we've got the idea of how a graph is built and how it develops. And I just call that a little activity grab bag. So you literally grab some tiles out of the bag. When you put them down, you can measure it. Now, a couple of other things can happen. Obviously, a child with a larger hand could grab more than a child with a smaller hand. So we could also do comparisons of who had more tiles, who had less tiles, and so forth. But I just want to give you the idea that the versatility of the color tile idea is a pretty key one, that we've done all strands or all aspects of mathematics. As I said, we've done some number and algebra, we've done some geometry and measurement, and we've also done now some statistics that sit inside there. Of course, you could do probability. And so same sort of idea. Imagine that I have a set of tiles sitting in a bag. So we're just talking about a drawstring bag. The tiles sit inside that bag, and we draw some out and we record which color came out. And then we might replace it into the bag and then do another draw and so forth. So we can do some probability things, same idea with the same tiles. That's why I quite like them. But here's a sort of, I'd like to tie it all together a little bit so we can see how all of these things fit. Often we talk about mathematics as being a universal language, or a language that can help us to really appreciate and understand the key ideas that are sitting here. So, for example, one thing that we just talked about was the idea of more or less. And so we started to use that language sitting in here. But I want to just set up a little puzzle. And as I said, we've got a sheet with a couple of puzzles on that you're welcome to download. But I want to explain how we can make our own version of that puzzle. So I'll put you back onto see where the tiles are, and we'll sort of develop how the puzzle works in itself. And the puzzle is really related to the mathematical language being used. Okay, so in this case here, what I'm going to do is I'll set up the puzzle so that you can see some words that we might use here. And I'll put a blue one in the middle and so forth. Okay, so in this case here, you start with what you start with the image or picture you want to start with, and then essentially, you start with the image that you want to finish with. But essentially what you want to do is give some clues that get us to that point. So let's think about the clues that we might give here. One is the number. So we might say, well, there's 5 color tiles. Okay, we might then say, well, there's a blue color tile in the middle or the center. So we start build that sort of language that sits there. We might say there's the same number of green color tiles as there are red color tiles. Now, what that's telling us is a couple of things. It's telling us sort of the numbers, because we know there's a blue one in the middle. It's telling us that, well, of the 4 remaining, 2 are the same color and the other 2 are the same color. So that's sort of helping us think this through. What it's not helping us with is the position. So we would need to give some clues about what they call positional language here. So for example, the only position we've talked about is there being a blue tile in the middle or the center. But if we head back here, let's just have a look and see how else we could describe this idea. So essentially we've got this blue one in the middle, but we don't know whether the rest of it's this way around or the way I had it around. So then we might say, well, there are 2 green tiles, 1 at either end. And so now you pretty well can't go wrong in developing those clues. So I want to take you through one of these conundrums. I call them color tile conundrums that sit here. And you'll start to see this. You're welcome to download this, but it's like a little puzzle that children can do. So while they're doing this puzzle, they might be learning concepts of number. They might be learning concepts of proximity. This is next to or adjacent to, or it's at the end, or it's in the middle, or it's above, or it's below. They might be learning some fractional ideas. So essentially, while they're doing these puzzles, not only are they learning the language of mathematics, but they're also learning some key concepts. So let me just give you an example, and I'll just read this one. I'm not going to do this though. You can download it and try later, but it says there are 6 tiles in a row. So that's telling us there's 6, but we don't know what the colors are. It says the first and last tiles are blue. So you can see it's pretty similar to what we just did with the one we tried to make up. The third tile is red. Now, is it from which end, the third tile? Well, because there's 6, it's not too bad, but we might have to talk about the second from the left. That sort of language might have to develop. It says there's a yellow tile between the red and green tile. So you start to see we're using the word between, focusing that idea of being between. And says there's a blue tile to the right of the red tile. So with those clues, you can get a unique solution that sits there. Now, I've put a couple for you to try, but I think it's when children make their own, they're more invested in it. So in other words, they like to make the puzzle. Now, I call them color tile conundrums. You can call them whatever you like, but it's really about blending the language, just language, but language of mathematics with the concept, in this case here, position, length, number, and those sort of things. Let me give you an example of another one. Okay, and just to show you how you can take the same idea but develop fractions ideas. Okay, so let's just, I'll take you down onto the screen here, and you can see that we could talk about the fraction idea. So let me make up a little model here. And in fact, we're going to start with something like 6. So in this case here, you can see that rectangle is made up of 6 green squares or tiles in this case here. Okay, now I'd like to look at a model that shows me what 2/6 looks like. Well, I could just grab 2 other colors. So in other words, because 2/6 of the model is red, we could say that 1/6 of the model is yellow. And we could say 3/6, or we could be really tricky and say 1/2 of the model is green. So you start to see how we could be putting some fractional language in it. Now, what's very neat about this is that there's more than one way to show it, and there's more than one, perhaps one way that we could actually build that model. So let me explain to you what I mean by that. Okay, so if you have a look back down here, you can see those elements of this being half, but actually we could do it this way. We could have 3 on this side, we get 2 on that side. So now we get to see that we've got 2/6, 1/6, 3/6, or you can see quite clearly that 3/6 represents half the area. So we're talking about that idea. But we could easily do this. So watch what I'm going to do. So I'm going to put 3 more green ones in. I'm going to put 2 more red ones in and 1 more yellow one in. We made a larger model, but in fact, the green still represents half of that model. This, in this case here, so now we've got 12ths. we've got 2/12 of that model, or 1/6 of that model is yellow. And if we looked at the red idea, we've now doubled that. So we've gone to 4/12, which is, you know, the same as we had before, the 2/6 or 1/3. So you can start to see how complex this can get. And all we did was what I call them color tile conundrums, but these puzzles that are based on words that link the words to the mathematical concept and the idea. And essentially, when you're teaching with manipulatives, there's a 3-step approach that happens here. You have the concrete idea or the concrete experience. Out of the experience, you develop this language. So you see how we've been developing the language. We get to then make a better picture. So we could do a drawing of that or a representation. Now, the final part of that process is when we start to use symbols. In other words, we write the fractions and show that, in this case, a half and a third and a sixth, or would give us a certain fraction of that. So you start to see how it all develops and so forth. And that's the general concept of the teaching of maths with manipulatives. So I hope that's been a bit of an overview. I know it was fairly quick, but I just want to show how versatile that literally these color tiles are.
Paul, thank you so much for that. That was amazing. We went through all 4 strands, as you said, so number concepts, geometry, probability, statistics. But what I did love is the development of the language. So even when you did when you're doing the graph, I'll tell you in the morning, yeah, the scale, using the language scale, axes and things like that. It's not stuff that you use in your everyday, you know, as you're driving a car and driving some school, or if you're walking to school or anything like that. So that was amazing. That was absolutely wonderful. Thank you so much. And also they're so versatile. So you can use them for the littlies. They can pattern and sort and not really realize what they're doing, but then you can ask them the open-ended questions about the color, where they're placed. And then when you get older, it comes into the graphs, and the fractions is another one. I love the fractions because it's visual. You can actually, using the yellow and the green, it's like the base 10 with the different colors. It's really a visual thing if you're a learner, if that's how you learn. I just want to say a big thank you. And I also want to say today a big thank you to the cameraman behind there. So Leland is the one that is putting the cameras up and down in Dr. Paul Swan's team. So thank you for that. You're showing everyone all of the different activities. Big thank you. The activity, the conundrums are going to be available on the website. Is that true?
Yep. Heather, we put a couple up for people to try, but I'd be really interested if people want to send us one. So if any children out there make one, feel free to send us one, and we might type it up and make it look really good, and then we'll share it with everybody. How's that sound?
I think that sounds wonderful. That's a very good idea. But thank you so much, Paul. It'll be available on YouTube channel, on Dr. Paul Swan's YouTube channel, and EDX Education's YouTube channel on the first Monday of the month. And thank you very much.
Thanks, Heather.
Nice day.